Welcome to The Explainer. Today, we're diving into a really wild idea that tries to tackle one of the biggest mysteries in all of cosmology. Let's get right to it. So, here's the question that keeps physicists up at night. We've known for a while that the universe is expanding, but the truly baffling part, that expansion is speeding up, pushing galaxies away from each other faster and faster. But why? And whatever's causing this isn't some small, minor force. Get this, it makes up almost 70% of everything in the known universe. It's the dominant component of reality. And we have basically no clue what it is.
Of course, we've given it a cool, mysterious name, dark energy. But here's the thought. What if it's not some new kind of energy at all? What if it's not a thing, but a property of space-time itself, like a cosmic tension that's been there since the very beginning?
Okay, to even begin to understand that, we need to completely rethink what reality is made of. This whole idea forces us to look at the universe through a totally new lens. So, try to forget the idea of space as just empty background. This framework says space itself is the fundamental stuff. It's an active, vibrating, oscillating field, and everything we see is just a behavior of that field. And this is a radical shift. The old way of thinking is that matter, like particles, exists in space. But in this new view, matter is just what space does. When the vibration of space gets twisted up into these stable, self-sustaining knots, we see that as a particle. It's not a thing. It's just trapped geometry. Okay, so if space is a vibrating field, and matter is just knots in it, then what was the Big Bang? It couldn't have been some explosion of stuff in the way we usually picture it. Right. In this model, the Big Bang wasn't a fiery explosion. It was something deeper. It was the moment a perfectly smooth, uniform space-time lost its perfect symmetry and fractured. Think of a flawless crystal suddenly developing a crack.
So the story kind of goes like this. In the beginning, there was just this one perfect, coherent vibration. But for some reason, that perfect state was unstable. It spontaneously broke, and the universe fractured into all these localized knots, what we call matter. And in the process, it left behind this residual tension in the fabric of space-time.
And this is where we get to the core of it all. This is the proposed answer to the whole dark energy puzzle. Because that tension, that leftover stress from the Big Bang, it never went away. This is the key idea right here. Dark energy isn't a substance. It's not energy in the traditional sense. It's the memory of that original, perfect state. It's this constant, built-in pressure of space-time itself trying to get back to that smooth, unbroken symmetry it once had. You could almost think of it as cosmic regret. It's like the universe remembers being perfect, and there's this underlying tension that can never fully resolve itself because all these little knots of matter and energy are basically holding the cracks in place. So, to put it simply, the universe is accelerating its expansion not because something is pushing it, but because space-time itself is trying to relax. It's trying to smooth out its own geometric scars left over from the day it was born. Now, if this idea is even remotely on the right track, the implications are just huge. It completely reframes how we look at the entire cosmos. So, just to sum it up, dark energy stops being some weird extra ingredient we had to add to the universe. Instead, it becomes a fundamental property of space itself. The universe isn't just a random collection of stuff. It's a dynamic whole that has a kind of memory, still reacting to the single geometric failure that started everything. And that's really the thought to leave you with. This whole framework takes our biggest cosmic mystery and says, well, of course that's happening. It has to happen. So it makes you wonder, if dark energy is just one of the scars from the birth of the universe, what other secrets are hiding in the geometry of space-time, just waiting for us to figure out how to read them?